to our next presentation. This is now a different subject, but also something which we saw in the previous session about geoinformation from aerial vehicles. This will be presented by Dr. Heiko Störkel. He is the founder and CEO of the company GeoMon, one of the companies at ISABIC Darmstadt. It's a pleasure to have you here. Mr. Störkel, please.
Thank you, Mr. Zimmermann. Hello, good afternoon, ladies and gentlemen. Thank you for being here. It's a really nice chance for me to present my young startup, which, as Mr. Zimmermann already mentioned, is incubated in Darmstadt in the ESA Business Incubation Center. Yeah, I would like to give you a brief summary. Who is GeoMon, or English GeoMon? When my colleague from university and I founded or got the idea of using unmanned aerial vehicles for economic reason, it has been 2 years ago, 2.5 years, and then nearly 1 year ago we founded our company, and so right now we are in the market since 9 months. The idea is that mankind always used nature, resources and so on for living. And this is a really nice idea, so we can survive on our planet. And everything could be fine. But is it? No, because man is changing the surface, and we are using resources because our wealth and our economy is based on resources. So we have to take care so that we can survive this resource, this high resource usage of mankind, and so we have to monitor our activities on the planet. But how? How can we generate geodata, cost-effective, high-precise geodata? Or how can we ensure highest precision of this data? And of course, how do we deliver easy, intuitive geodata to the customers? Well, we thought of partly already existing technologies, and so we came up with a conclusion, and we called it, as a product name, 4D environmental monitoring. So this concept is based on three main components. The first one, which you can see on the left, is the unmanned aerial vehicle. This is also known as drones, and for startup, we used one system which has been developed by a former ESA Business Incubation Center incubatee, which is called Pavilion. So we thought this system is really performant, so we used it and built our service on top of this system. It's a fixed wing UAV, and really good use on smaller areas up to a few square kilometers. The second component of the 4D monitoring, environmental monitoring, is of course the processing of the data and further analysis. Because if you have the basic data, this is a nice picture or a 3D image, but the specific knowledge which we as geographers can put into the data, this is what engineers and actually the customers who work with landscape, who need to monitor landscape, that they need and that they use. And the third part you see on the right of the graphic is the data delivery, which means how we deliver data to the customers. This can be as in a conventional way, the paper map, paper chart, or of course digitally for downloading, or we could also host it in our own cloud service. We deliver high-resolution orthophotos up to 1.6 centimeters per pixel, and of course we have also a high spatial accuracy. We use, I think many of you are familiar with the system of differential GPS. So we're actually using satellites, GPS satellites, GLONASS satellites, and hopefully soon we're also using Galileo system satellites. And we add a stationary antenna on the ground, on a fixed point, where we have coordinates, and then we have the corrected value of the satellite time, and so we get the differential GPS, DGPS, actually on the plane or on the data. And also what you can see on the upper left of this image is that we can also add cross-validation tests to ensure that the position of the data is actually on the right spot. Yeah, you noticed that image at the beginning, I guess. So this is one result of a project we picked for the presentation. It's quarry recultivation in Germany. And so since 12 years, companies are backfilling that hole, and GeoMon was asked to deliver high precise geodata in the result with how much volume is left, how much do we have to backfill to close this hole. As I said, since 12 years this project is going on. People are worried that it will never be filled. They say that by night people carry out the dirt again because the hole actually isn't closing. And yeah, this is just an image of what we could do as analysis. You remember the second part, the second component of our concept. So here we have, of course, measurement of length, of points, of areas. We have volume estimation, mass calculation. But the most important thing actually when we're talking about surfaces is the change detection. How did from one date of data acquisition to another date of a second data acquisition, how did the surface or the object change? We also can include, which is named here or entitled with the dynamic swipe function, we could also overlay the images because they fit so nicely. I mentioned the high accuracy, and then we can really see the changes, which is one part where we call it intuitive geodata. This is actually a result that we sold. It's a map of the change. The red lines, the red lines you see is the planned nivellement that should be reached, and the black lines not so easily, but you can see them, I guess, show the state at the moment, the status quo. So actually there's a difference of about 10 to 15 meters in this hole that they're backfilling. Yeah, and the next thing that we would like also to develop in the environment of ESA Business Incubation and together with universities and maybe some other companies is that we are getting away from maps. So the most important part is to put the data into tablet systems or whatever there's going to be in the nearer future, maybe some flexible fibers or something that can present data. And so we are developing an app where you can include the geodata on your tablet or mobile device. And of course this should include features as your position, because then you can see on site where you actually are, and the measure or the building object, or I don't know what, where it is. Is it in front of me or should I turn around? I mean, of course you should know your site, but sometimes it is just easier if you really know where you or the incident or whatever you're looking at is. We also would like to include the swipe function. That's the right image you see there on the tablet image, and there should be developed with the people that are actually working on site. So we will develop it with feedback for every developing step. So if they say, yeah, it's really neat if we could include some photos, then we say, okay, you get that. If they say this is ridiculous, then yeah, we won't include that, of course. So I gave you a short introduction what GeoMon does. We capture the images I told you, we calculate and post-process the data, and also we deliver the data to our customers. And development doesn't stop. As I mentioned on my last sheets, on my last slides, we will yeah, go ahead and develop further in cooperation with ESA and ESA Business Incubation Centers and universities. And yeah, I would like to thank you for your attention and hand back the microphone to the next speaker. Thank you.
Thank you for your presentation. Are there any questions from the audience about company GeoMon? So this only means that the presentation was extremely clear and that you can expect lots of visitors at the booth of ESA. So thanks. Okay, are there any questions from the audience in general about business incubation, starting your own company, entrepreneurship, and how ESA